In this video, we're going to look at what OpenAI's video pre-training, the VPT model actually does. So they have this nice blog post. I'll link everything I've included in the description below. There's a nice blog post which explains kind of the big theme that they're doing for Minecraft, but we're going to actually dig into the code using Colab. So you can see here that this is their blog post. We can also move on to the GitHub repo where their code lives, and this not only has the code in PyTorch, but also includes how to set it up, what models there are to download, and we're going to be playing with this today. So I guess one thing I also want to point out is that the source code which I'm going to start with is based upon someone called Ven on Discord. So how did I find that code? Basically, I went to the AI Crowd MineRL Basalt Challenge, which is kind of where we're heading with all this. On there, they point to a Discord channel. Discord channel looks like this. I'm MDDA on this Discord channel, and people are posting a variety of interesting links and notebooks on this channel, and tips and tricks. So hopefully this develops into being a very useful resource. But from here, I got to Ven's Collab, which is all about the Minecraft or the MineRL or MineRL VPT, and just having a look at seeing what this is about. So I'll put a link to the original Ven MineRL notebook in the description, but I'll probably also have an updated version of my own, simply because in the previous video we did all this setup of the MineRL gym environment and then saved it off into Google Drive. So that's actually very time saving rather than running this directly. But what I'm going to do is just walk through what is going on here so you can see it. I'm not going to run this one myself because I've got an updated version of this to play with YouTube videos. Okay, so here at the beginning of this, we go through installation of the Java Development Kit, the JDK, and also the MineRL or MineRL installation. This takes a fair amount of time, which is why I built this one, which essentially saves it off as a tar file in your Google Drive so that you can install it once and then reuse it really quickly. Okay, but let's just go with the installation as originally done here. It also installs some other virtual displays, which is what you need for running the environment directly. And then having set it up, we then load in the model. So this setup of the model is basically downloading from the GitHub repo the original model, and also the model code, and also the weights for the model that are required. So having done that, we can then actually run the model for a number of time steps, and here you can see a loop of going through all of these playing steps, getting the actions that the model wants. So this is the VPT model with a particular checkpoint, and the checkpoint it's got downloaded is this early game weights. Basically it likes to play as if it's playing in the early game. So this is this is the OpenAI model, which is trained on the basic things that people do when they start a Minecraft game. Okay, so what's it going to do? Basically, every time it sees an observation, it will actually take in what is the world telling it, which in this case, for this MineRL in this year, is basically I think it's a 640 by 360 video display of what's happening in the world. So having got that observation, it then converts that into an action, and it then passes that into the environment saying, okay, I'm going to take this action at the next step. And so every time it does this step, basically it's taking one new frame of action, which is done at 20 frames a second in this gym environment. And so it will keep doing this 20 frames a second until it runs out of these play steps to do. So this is kind of interesting. You'll see that it basically every frame it gets, when a frame looks like this, it's going to decide, okay, what action will I take next? Now the interesting thing which you'll see here is if it's actually going to run this through, and I think here it may be one of the runs by the diamond player, you'll see what it's going to do is it starts off pretty near a tree. Hopefully you can see this on the screen. It does a little bit of water diving, then it chops down tree. This is a 30-second clip, so it chops down tree, or leaves it hanging maybe, makes a crafting table. In an ugly way, it pickaxes it. Now it digs straight down. Now this is kind of classic thing not to do in Minecraft, really. It's now made itself upgraded to a stone pickaxe, and it's chopping up the crafting table again. So you can see from this play, its basic strategy in order to get to diamonds as soon as possible is to chop down a tree and then dig straight down. So in many ways, this OpenAI diamond orientated player is not a very good Minecraft player. It's just going to get the diamonds to make a diamond pickaxe in the most efficient way possible, which is probably not a very good tactic in the early game of Minecraft. It's not searching out food, it's not doing all the things that you kind of want to do. It's going to dig down, and if it's unlucky to hit lava, then it will just die. Apparently someone else did an analysis of how these players work. Once it's found the diamonds, it will just wander around until it starves to death. It has no kind of concrete plan beyond getting the diamonds, which is not surprising given the way this is trained. It's trained purely to be reward orientated, and the reward it's going to get is going to be for getting the diamonds. Post that, it will have no clue about what to do. Okay, so this has been just an introduction to using this VPT for interacting with the environment. Now we're going to move on to, can we use it for YouTube videos so we can actually start to see what we could start to train ourselves. So this Collab Notebook, which I'll have a link in the description below, is all about applying the video pre-training VTP to YouTube video. So this is the kind of thing you'd want to be looking at if you're going to be training it on video clips. So training models on video clips, there's going to be content in here which is kind of useful. Alright, so what this will do is, it's kind of nasty, because I want to only use the barest minimum I can, rather than installing all of the things into Collab every time. So here what I do is I install the VTP repo, just as we saw before, if it's necessary, so it checks is it there or not. It installs Gym3, which is the OpenAI environment for doing reinforcement learning, because this is actually used by the VTP repo itself. So that loads in a bunch of stuff. It gives an error message saying I have to restart. This isn't actually necessary, it doesn't require it. Then I load in the different model config and weights. So there's a small download for the config and almost a gigabyte download for the weights. And then, having set up the agent parameters here, I then load in the pieces of the MineRL or the MineRL repo that I need. It turns out only 2 files out of this repo are needed, and if I install the entire thing, that's a 22-minute process. I don't want to do that. Now I understand from a programming point of view, I really only want to include the stuff. I don't want to repeat myself. I don't want to copy and paste stuff between repos. On the other hand, if you look at the OpenAI, the way the OpenAI thing is coded, this Herobrine hero constants thing is included in a very limited way into the VTP repo. And so definitely one can criticize me for putting this into my Collab in this kind of really hacky way. On the other hand, you might turn around and point the finger. I wish I could edit the VTP repo to actually make it so that they don't require me to repeat, require this repetition. In fact, one of the things which they do, having downloaded these tiny files, they also require that the environment you pass it complies with whatever they're going to produce. Now this makes total sense from their point of view, in that they want to make sure that the model is producing outputs and actions which are going to be compatible with the gym environment which it's going to be interacting with. On the other hand, in order to make sure it's compatible, they've actually copy-pasted some of the things from the MineRL thing in the first place. So there's a bit of kind of duplication already built into this. So I don't like doing this, but this works. So what I do is I create a fake environment, copying the bits out of the VTP agent, just the stuff which is necessary to persuade it that I do have a genuine MineRL environment, and it will interact with me afterwards, after it's set up. Okay, so this is kind of a fake environment I've set up. It thinks it's a MineRL environment because the first time it checks it, finds everything is exactly like it wants. Okay, so having done that, I can then pull in a MineRL agent from VTP, and this is loading up the weights. It loads it. This is actually only using a CPU instance. So if we look at this runtime type, I've got no hardware accelerator. It turns out that this thing is not terribly inefficient. Of course, having a GPU would be better, but in the idea of having a minimal setup, I haven't even loaded the GPU. This will work with the GPU because I do have a line which will do the CUDA version if required. Alright, so having done that, I also load up FFmpeg because I want to be able to assemble and take apart videos as I do this. So we're about to go into the details of what is required to make a demo video usable by VTP. In particular, we're going to want the resolution of the video to be correct with the field of view, which basically we can't really control from a video we download from the YouTube, but we do need to make sure it's going to be at 20 frames a second, because this is what VTP is set up for. In the Minecraft.py defines the milliseconds per step as being 50, so we know it's a 20 millisecond step, a 50 millisecond step, 20 FPS. Okay, so having got the FFmpeg, which is a good thing for, in particular I'm going to address it through the Python API. This will allow me to manipulate a YouTube video into the correct format. Now what I've done behind the scenes on my local machine is I've done a YouTube DL for a YouTuber who I found has done like a demo which seems suitable. I don't want to run YouTube DL on Colab because I'm pretty sure Google will not want me to do that. So I don't want to be offending any of the Collab gods in doing what I do. But basically, I found this from Bitten Gamer, some Minecraft video where I looked for videos which were about kind of early game, building a house, that kind of thing. There is a whole video here which I've downloaded on my local machine, and I've made it so that sorry, let's stop this playing. There we go. I've got this on my local machine, and then I can upload it to Collab. So if you look in my list of files on Collab, I've got this how to make a basic house as a video in my home directory. So having got this video downloaded, and I've got the right file name set here, I then have I use the FFmpeg Python version to actually load in this video, trim it to a particular start and duration, and then output it at the correct resolution with the correct frames per second. So this is basically manipulating it so it's just like I want it. Okay, so from there I can then make my video segment, which I've actually annotated as being at 20 frames a second, starting at 65 seconds in for 5 seconds. I've taken a small segment of this video because this looks interesting to me. So this is the kind of video you get out. It doesn't look that different from what you've seen on the YouTube page. Fortunately, Creative Commons license, so I'm fine to play this through here. You can see that basically it's going to just do parts of building a house with a pig wandering through. Other interesting things is he's built the corners of the house with just plain logs, and we'll see how that kind of impacts us. Okay, so now we have a small segment, a 5-second segment of video, which turns out to be, I guess, 100 frames. And then what I want to do now is see what VPT will say about this video. What actions does it want to perform for each frame that it sees. Now this is slightly different from how OpenAI trained their model, in that first they trained a model which deduced what actions were performed between every pair of frames. Now that model hasn't been released. In the repo they suggest there are issues. They suggest they are going to release that model, and that model seems like an important step here, because to actually work out what a YouTuber is doing is an important part of training our own models. If we had videos that we wanted to train on, that would be an important model to have. Anyway, as it stands, what we have is a generally pre-trained model, all of which is essentially causally trained. It's trying to predict what would happen next in the early game. So what I've done here is I've commented it out because I've got a piece of code which works now. But basically the actions, the set of actions that we can perform include things like attacking, yes or no, going backwards or forwards, yes or no, choosing items from the hotbar, or moving the camera. So this is essentially the same as moving the mouse. So what I then made up is a little function which essentially prettifies an action by making it so it can pretty print these things. What I'm going to do is I'm going to call the VPT thing repeatedly with the frames of the video, saying, well, what actions are you going to perform? And I want it printed out nicely. Okay, so what I do here is I just check. First of all, I just check that the video is in the right format, the right frames per second, and then while the OpenCV video reader is going through this, it's going to read a video frame. It's then going to get the action for the point of view of the frame, which is basically, this is all that the VPT thing knows as input. Then having got this action, is then going to pretty print that action. Now what we see as output, and so this is basically going to be 100 actions it's going to do, is it shows that the cam is going to, it will want to move the mouse, right? At every scene it's been given, plus the history, you can see that it's trying to move the mouse. It doesn't get to move the mouse because it's being told what the next frame is by the YouTuber who's made those frames. You can see that based on its early game experience, the VPT thing is looking to move the mouse around, doing some attacks and some forwards, and you can also see that it's trying to attack and move the mouse and attack a bit. So what I think is happening here, and this is where the kind of the textual output falls down, is what I think it's doing is when it sees a log coming into view, it wants to move the mouse so it can break the log, because its instincts are to go to a tree, break the logs, so it can to make tools and dig down, kind of thing. So this is kind of very illuminating the kind of things that it wants to do. What I'm going to do so this is like an interesting notebook in itself, and you can definitely apply this to your own videos. This is or videos you find on the internet. It seems to do like appropriate kinds of things. Sometimes it will do multiple actions in one time step. There's a place where it will go forward and right. It's chosen to use something in its hotbar. What I'm going to do next, so this is kind of a prelude to the next video, is going to be how do you actually use your own videos, i.e. can I use my Android phone and get it so that I can record a video and then overlay on top of it like what actions VPT would like me to be doing. So I thought that this is the first step in a two-part process. This is doing videos from YouTube. Next off, we'll be doing videos from our own. If I'm doing it on mobile, it's going to be a Bedrock video. So we'll see whether that works using VPT. Hopefully this has been an interesting intro to what VPT is doing under the hood, or is doing in a hands-on way. And later videos I'll probably be taking apart VPT and maybe re-implementing it in JAX, just so we can see exactly what's going on. Anyway, hopefully this has been an interesting second video in a series, and I'll talk to you next time.